So now we're going to work on solving quadratic equations by completing the square when A is a perfect square. So let's review again what A actually is. When you have a quadratic equation similar to this, let's put it in quadratic form. No, ax squared in standard form rather plus bx plus c equals 0. The leading coefficient is a. The second term, the coefficient is b, and the constant in the back is c. Okay, so when my a is a perfect square, now let's review what's a perfect square. It means a number times a number times itself will give you that number. Example, 3 times 3 equals 9. 9 is a perfect square. 16 is 4 times 4. Perfect square. Okay, so when this leading coefficient is a perfect square, and we can check it, right? We have, okay, there's my leading coefficient, 9. I know I can solve this by completing the square. At least it's a good strategy to work on when I have x squared and an x, and there's no c, right? There's no third term here, and there's a number on the other side. So I look at this and I say, okay, well, this is a perfect square. So I am going to go ahead and try to figure out what this is and what this is. And I'm going to see I'm going to complete the square here and figure out and take the square root of both sides. So which is the basic formula that we use to figure out how I'm going to make this a perfect square? Well, actually, I got a little ahead of myself. Let's wait on that, okay? All right, so here we go. We are going to take, for this specific equation, my A is 9. My B is 6. My C, I don't have anything. So I'm going to put 0, okay? Now I'm going to put that into here. B squared over 4A divided by 4 times A. My B is 6. That's the coefficient in front of the second term, the x to the 1 power. So 6 times 6, that's 6 squared, right? And then my A, I always multiply 4 times whatever A is. In this case, it's 9. Now, none of these cancel out, and I write it out that way because sometimes they do, and it makes life a lot easier. So we get 6 times 6 is 36. And 4 times 9, hey, it's 36. What is 36 divided by 36? Well, that is 1. Pretty simple. That means the number I'm going to add to both sides is plus 1. Plus 1. Whatever I do to one side to make this a perfect square, I have to add by the same amount on the other side. So let's cross this ugliness out. And let's rewrite this. Okay, so we have 11 over here. And on this side we have, I'm going to write it out like this so you can see it. This is a perfect square. And in order to make this a perfect square, it has to be the exact same thing in the parentheses. 9 is 3 times 3. So that would be 3x times 3x is going to give me 9x squared. And the 1, look at my second term, it's positive, so it's going to be plus 1, which is exactly what we'd have here, plus 1, positive 1. And this gives me 3x plus 1 squared equals 11. Now we're going to take the square root of both sides. Square root, square root. We get 3x plus 1, the square goes away, equals, now 11 is not a perfect square, but that's okay. We just write plus or minus the square root of 11. In a word problem, we may have to figure out what the decimal is, but we can just leave it like that. And in upper level maths, you just leave it like that. Don't worry about it. We are now going to solve for x. Well, the first thing we do is we move whatever is plus or minus to the x. So we're going to take the subtraction property of equality, right? All right, minus 1. 3x equals plus or minus the square root of 11 minus 1. Now you got to be careful here, okay? I'm going to go ahead and separate this, which I probably should have done over here, but let's just do this. 3x plus the square root of 11 minus 1. And, sorry, 3x equals the square root of 11 minus 1. And then 3x equals the negative square root of 11. This is the positive one over here, minus 1. So this is the positive side, and this is the negative side. If the square root of 11 is a positive number, because remember, let's say it's it would be something like, let's see, 3.4-ish. If it's negative 3.4-ish times negative 3.4-ish, it's still going to give you positive 11, but it's actually multiplying two negatives. So that's why you get the negative part of it. And it could be 3.4-ish times 3.4-ish. That's why you have the positive version, right? Okay. And now we're going to divide both sides by 3. Now, that gives me, I'm going to rearrange this. We usually put the number in front and then the radical behind, because sometimes you can confuse that number underneath the radical. So that's a little bit of my bad. I'm going to change the position. I'm not having a good night here. X equals negative 1 plus the square root of 11 divided by 3. It looks like a little bit of a mess, but this is just a decimal plus negative 1 divided by 3, and you would get this as a decimal or leave it just like this. This would give me x equals negative square root of 11. Notice how this was a positive square root of 11 minus 1 over 3. If you notice, the minus 1 and the positive 3 are exactly the same. The only thing that's different is plus 11 minus 11. And I'm going to put that negative 1 minus the square root of 11 divided by 3. I can just switch it over. It's still negative 1 and it's still negative 11. These are my two answers. Look at them. Negative 1, 3, negative 1, 3, and this is just plus 11, the square root of 11, or minus the square root of 11. And that's how you find the perfect square when the leading coefficient is a perfect square, which 9 is. 3 times 3 is 9. So let's take a look at another example. Hopefully this will be a little easier. That one had like square root staying. I'm not sure if this one does, but we'll figure it out. First, I look at this problem and I say to myself, okay, I don't have a C, so this is probably filling out, adding a number to both sides to make it into a perfect square. So this is a completing the square problem. That's a good way to, that's like a good indicator. So I look at it and I say, okay, let me look at my leading coefficient. It's a perfect square. This is the formula that we use to find out what I'm going to need to put here to make it a perfect square. So I figure out, what is my A? 16. What is my B? Negative 16. What is my C? 0. The number's on the other side, so that doesn't count for 0. Okay, I'm going to go ahead and underneath here, I'm going to use that formula. B squared, negative 16 times negative 16. That's B squared over 4 times 16. Okay, now these two negatives, they cancel each other out because when you multiply two negatives, it's a positive answer. Okay, so I'm going to cancel out these negatives. And this 16, a 16 there, and I get 16 divided by 4, which is 4. That is what I'm going to be adding to both sides. Okay, so I'm going to add 4 and 4. Okay, so we do that. And we get 16x squared minus 16x plus 4 equals 9. All right, now we want to make this, 9 is a perfect square, so that makes me happy. I know that this is a little bit of an easier problem. We need to figure out this perfect square. This times this equals 9, right? 16x squared. Remember, it's going to be the exact same thing because that's the definition of a perfect square. You're multiplying it by itself. So 4x, that'll give me 16x squared. And the 4 will be, this is negative 16x, that middle one. So this is going to be minus 2, which when you multiply the 2, you get 4. Okay, so then when we get the middle piece, the negative 16, it's negative 2 times 4, and 4 times negative 2, which is negative 8 plus negative 8x is negative 16x. And there is my perfect square. This times itself. And 9. The square root and the square root, I get that x alone. This square root cancels out that square. 4x minus 2 equals, what's the square root of 9? Plus or minus 3. Okay, let's do the positive side. 4x minus 2 equals 3. The negative side, 4x minus 2 equals negative 3. And we just solve for x. We add 2, or we just move the 2 over. 4x equals 5, and we divide by 4. X equals 5 divided by 4. And we're going to leave it as a fraction. We add 2 to both sides. 4x is negative 1. We divide by 4. X equals negative 1 over 4. Now, here we have our two solutions, and we're done. If this was a word problem and then we're talking about distance or how much area or how much width, we know the negative number wouldn't work. But it's just a problem that we're solving. It could be a positive or a negative number. And those are our two solutions. So we use that completing the square, this specific shortcut to finding out what I need to add to both sides in order to create a perfect square here and solve what x is. And there you go. I hope that helps. Good luck with the work that I assign.